Okay, these are the MAT 1140 notes. This is chapter 4.5, page 2, the last page. So we're back on errors. We've got an absolute error, which is the actual difference between observed and the actual value. So I am going to change up colors here so I can color code these for you. So our absolute error, difference always means we're subtracting. So anytime you see the word difference, we want the difference between the two numbers. We figure that out by subtracting. So we are going to take the observed value and we're going to subtract the actual value. We get an error of 0.2. Notice I went observed minus actual. That means my observed value is 0.2 liters more than my actual. Oops. To find the relative error, we are going to go ahead and take our absolute error and we are going to divide it by the actual value. We get 0.003996. I'm going to go that far even though I'm going to round probably to 4 places. Let's go to 4 places. 0.0039, but the 9 behind it rounds this up. So 0040. There is our relative error. To find our percent error, we take that relative error and we multiply by 100 or 100%, however you are looking at this, and we get 0.40 or 0.4%. So there you go. There is our absolute error, our relative error, and our percent error. Okay. So let's talk about precision. Whenever we are add, subtracting, multiplying, or dividing, we want to make sure that everything is in the same unit of measurement. So here I've got 9.3 kilograms, 1.8 grams, 42.7 grams, and 18.932 grams. That 0.93 kilograms, remember to get from kilograms to grams, we multiply by 1,000. And so when we do that, remember every time we multiply by a 1 with a 0 behind it, we move our decimal 1 place. This makes this 930 grams. So I'm going to add. I'm going to make sure that if I'm adding by hand, I am lining up all of my decimals. No reason to really do that. Sometimes it's nice to just double check and make sure we haven't lost this skill. So as a reminder, I would add in zeros here. So everything is carried out to the place value, same place value. And then I'm going to go ahead and add straight down. Now, I get 993.432. Remember, this is in grams. When we talk about precision, we want this to be as precise as the least precise measurement, least number of significant digits. So this one has 2 significant digits. This one has 2. This one has 3. This one has 5. So we want an answer that is correct to 2 significant digits, which means we got a whole lot here that we're going to ignore. And this becomes 990 grams. If we carry this to 2 significant digits. Last one is distance and midpoint between 2 points. Now these are points in 1 dimension. So distance and midpoint, we're just going to distance. To find the distance, we're going to subtract. With the reminder that when we subtract fractions, we don't need to multiply up there. We need a common denominator. Now I cannot take 6/8 away from 3/8, so I'm going to borrow 1 whole. Keep in mind that's 8/8. There's my 1 whole right there. I now have 11/8 minus 6/8. That I can subtract. That gives me 5/8. I've got 11 minus 3, which is 8. So 8 and 5/8, whatever this is measured in, inches, feet, kilometers. To find the midpoint, we are actually going to add these two. Again, I need a common denominator. Nine eighths is bigger than 1, so I'm going to pull that 8/8 out and make this 16 and 1/8. That is the numerator. So now I need to take that and divide it in half. And I can divide the whole number part by 2. 16 divided by 2 is 8, and then I can divide the fractional part by 2. Half of 1/8 is 1/16. So 8 and 1/16 is halfway between 12 and 3/8 and 3 and 3/4. And we may not be crazy about doing that with fractions, so let's try this with decimals. This time I do have a label. I have centimeters, so I'm going to make sure that I include that. I'm going to borrow there. 12 minus 8 is 4. I'm going to borrow there, and 12 minus 7 is 5. I get a distance between these 2 points of 0.54 centimeters. To find the midpoint, we're going to add these two and divide by 2. And notice here I am being better about using the formula. It gets kind of confusing when we try to write that formula with all those fractions. If we're doing this one step at a time, I get 10.1 divided by 2. or 5.05 centimeters. That is going to be the point directly in between the other 2 points.